Okay, so let's see if we can walk through one of these problems. I went ahead and changed up these dimensions from what's in the book and what's in some other places. The idea for all of these is you're going to know one cable, or maybe you know the weight, you know one piece of this, and you have to solve for the rest of it using equilibrium. So forces in the XYZ direction are all going to add to zero. We end up with three equations, and so we can solve for three unknowns. So let's start out, and let's say we have AB, that we know the tension of it, and we're going to figure out everything else. So the first thing to do is to split things into XYZ components, and we're going to do that with unit vectors. So there's a cable, and the cable has a length and a direction, and then there's a force, and that force has a different length. But because the force is in the same direction as the cable, it turns into a bunch of similar triangles. The ratio of all the sides is the same. Okay, so here's AB, and it's pulling down and back. So if we look at what directions we're going in here, so this is going to be 500 down in the Y direction, and then for our Z direction here, we're coming all the way through this 450, and then the X direction is going to be negative, and it's going to be this negative 325. So let's go ahead and fill those in. Hopefully you can see this. There's two triangles, right? There's one triangle that's kind of standing up off the ground, and there's another 90-degree triangle that is on the ground. And we're just walking around the sides of that triangle to break the vector into its components. Okay, so in the X direction, we said that's going to the left, so that's going to be negative 325. Y is coming down 500. And Z, in this case, is the only one that's going forward in the positive direction. So we have the XYZ lengths, and then this would be the overall length of the cable. So if we took the X squared, Y squared, Z squared, it's kind of like A squared plus B squared equals C squared. You walk around the bottom triangle, and those are those two sides squared, and then the top triangle gets another squared to it. There's another way to add squares in quadrature there. Okay, so fraction, this is the unit vector. This is what we're really interested in. So we want to see how much of this is in the X direction and what the fraction is in the Y direction and what the fraction is in the Z direction. And they call this thing a unit vector because all those fractions, if you get the overall length of that, it adds to 1. So it's another little vector, and that vector has a length of 1, and the sides of everything are the fractions we need to split our force up into its XYZ components. So let's say this is the one where we actually do know the force, and we're going to take that and multiply it by these unit vectors, and that's going to break this up into its XYZ components. And you can always check that that everything works out at the end by seeing that XYZ adds back to the original force. Okay, next two cables, let's say we don't know these guys and we don't know the weight. Start with what you do know. We at least know the dimensions of this thing. So for AC, we can at least fill in kind of the lengths of the cable and the unit vector, even though we're still having to figure out what that force is. But we can at least get a little bit of a start on this thing. So once again, we're going to pull down 500 in the Y direction. For the X direction, we're coming all the way forward for this 425. And then in the Z direction, we are coming forward 450. So down, forward, and forward on this one. So we can go ahead and fill those lengths in. So that is 425 in the X, coming down in the Y, and forward 450 in the Z. Be real careful we get this down, plus, plus in there. And once we have the unit vectors in one of them, I can actually say Control-C, Control-V, and that will give us the fraction in the x, the fraction in the y, the fraction in the z, and sure enough, it adds to 1 again. Last one, we'll do the same thing for cable AD. So we're pulling down on this, and then we're going forward 300, and then we're going to go backwards this 550. So again, we're looking at two triangles here. One triangle that is standing up and another triangle that is here on the ground. And we're just walking around the XYZ lengths of this thing. So here is our X direction. We're going forward. So we'll make that positive 300 millimeters. And they all come down the same amount. And Z in this case is negative 550. It's real easy to get one of these lengths in wrong, so that's another reason to kind of set these up in Excel, because you can go back and check that you have the signs right. So forward, backwards, and down. We should have two negatives, and only X is in the positive direction here. Okay, next comes the kind of tricky part. So we want everything in the X direction to add to 0, everything in the Y direction to add to 0, and the Z direction to add to 0. So I'm going to just pull in here what we have. If I look at this thing and we just think through what forces are going on, let me just zoom in here. So we have the three tensions are acting down, and those are going to get held up by the ceiling. And the ceiling is only going in the Y direction. So we have 4 different cables coming together. I'm going to call the ceiling just A, and I know that it's in the Y direction, so I can fill in these zeros. AC, I do not know what these guys are. And this is the next thing to kind of figure out. Looking at these rows in the X direction, I have 2 things I don't know in the X direction. The Y direction, I have 3 things. And then Z direction, I have 2 things I don't know. So I'm going to go ahead and try and go for these guys first as 2 equations, 2 unknowns. So that'll hopefully make things a little bit easier. Okay, scrolling out on this thing, and hopefully the video you'll be able to see the numbers, because I want to just write the equations here for a bit. Okay, I'll go ahead and so let's start with the forces in the X direction, and those have to add to 0. So I'm looking at AB in the X direction, which is this negative 348. That's one of the cables. And then I also have AC is tugging around in the X direction. This is actually going positive this time around. I don't know the value of this, but I at least know the unit vector. So I'm going to go ahead and say it's pulling in the positive direction, and this is going to be 0.53. So that's the fraction of what's going on in cable AC in that X direction. And then for AD, once again, I don't know the number here. I know it's going in the positive direction, and I know the fraction of it. So I'm going to fill that fraction in. So here's my 0.374, and this is the tension in AD. And all of these guys are going to add to 0. There's nothing else. The weight is not in the X direction, so I'm good there. Okay, so there's my 3 tensions adding to 0 in the X direction. The next one, I'm going to look at the Z direction, because then I don't have to worry about the force at A. So here we go. The force in the z direction adds to 0. Maybe I'll go ahead and just draw this equation right down here, but that's what we're going to do here, the z direction. So for that first AB, I have positive 481. And then for AC, I'm going to have this 0.56. So forward, backwards. So AD is going to have to fight both of these guys. 0.68 AD, and those are going to add to 0. Okay, so 2 equations, 2 unknowns, and you can go through and solve this however you want. Maybe I want to, I'll get rid of TAD. So if I take this whole first equation and maybe I multiply this thing by, I'll multiply it by this 0.68 divided by 0.374. I'm going to call this just R for a ratio. So if I multiply this, then I'll get 0.68, 0.68. I'll be able to cancel this out. And if I add these 2 equations together, and I don't know how you were taught to do this kind of stuff in algebra, solve it however you want. Okay, so here's this ratio, negative 348 times the ratio plus 0.53 TAC times that ratio. And then I'm just going to keep adding this stuff on, plus 481 plus 0.56 equals 0. So then let's just, combine like terms, right? So TAC times ratio. So there's my TACs, and that's going to be equal to 348 ratio minus 481. What I want to do here is actually, I'm going to click on these numbers in the table and enter this final equation right in here so that I can get a more accurate number. And I'm just kind of keeping track of the main gist of these numbers right now so that later on I can find the right cells to put in. Okay, so this is the equation that I'm going to try and then put in here. And we'll try and solve one of these. This is a little bit tricky. I'm going to try and, okay. So just to make this a little bit simpler, the ratio that I'm after here is just this z versus x. That's what we're going for. And I don't want it to be negative. I'm going to say, just get rid of that negative sign. Okay, so that's the ratio that I'm going to multiply this x equation by so that I can then crank through and solve for what AC is. So here we go. I'm going to say equals, and I'm not going to type in 348. I'm going to make sure the sign, it's negative here. So, okay, negative of this 348 times the ratio, if I can keep this, minus the 481. So we're going back and forth between this x and z equations, and then divide by, and 0.53r. Let's see, that was from AC. 0.53 times r plus 0.56. That was all from this guy. Okay, let's see if that... So once we get attention for AC, I'm going to go ahead and split that into XYZ components the same way we did before. So I'm taking that magnitude and multiplying it by our XYZ components. I'll show you how to use the solver for this as well, because that will make it a lot faster. Okay, so now we have our AC, which means that we can get our AD really easily, right? We want to make sure that all of these guys are going to add to 0 at the end. And the way to do that, so for everything in the X direction and the Y direction and Z, it's not adding to 0 yet because I don't have those last pieces filled in. But this is going to have to be equal to negative of this plus this. Okay, yeah, if you're doing this with a calculator, chances are there's going to be so many rounding errors by this time, it's just going to be a mess. Okay, so now we have part of AD. I have the X component of AD. Let's go ahead and, so if Fx is equal to F times that ratio, right? So then what my force is here, my force is going to be equal to the X component divided by that ratio. So instead of multiply it, it's divided by. And now that we have this guy in here, we should be able to get the Y and Z components, fill in the rest of the table. So here's my Y component, and here's my Z component. And woohoo, our Z is added to 0. Beautiful. The last thing is the weight, and it looks like that's what the ceiling is going to have to pull up. So equals negative of all of this stuff, right? This plus this plus this. So you can see for this one, I had to do a few things by hand over here. And it was a bit messy, but it was still just 2 equations, 2 unknowns. So it was doable. And, but yeah, these guys are a bear. They are a bear to get through. For this next little bit, let's play around with Excel's solver up here. So what I'm going to do, right click, move or copy, create a copy, move to the end. So this will give us something to just play around with. So let's say I know 800. I do not know the rest. I'm going to move this around a little bit just to get all 3 of these in a row. And we're going to try and mess around with that solver. So the 800, that stays as is. And the rest of this, so I have my original work over here, so I don't feel bad deleting this. So I want to make sure that these guys are all attached to one another. Okay. And for the solver, what we're going to do is we're going to have to start with a guess. And I'm going to cheat a little bit. I'm going to say, oh, this is around 100 and 800, which is kind of interesting, right? That AC is so much less. I guess AB and AD are sort of at odds with one another. So if those 2 are kind of equal and opposite, and AC isn't doing much. So we'll put something in here as a starting guess. So these are not the correct answer, but for numerical solutions, you need some place to start. Now, okay, so here's AC, and I am going to link it up here to our guess. And at AD, I'm also going to link up here to that guess. And I'm going to crank through this as if that guess was correct. So I'm using that guess to split everything up into XYZ components here. And same for this. And it's not going to add to 0, and it's not, hopefully I've got at least a ballpark. If you don't have a ballpark starting guess, it's not going to work. Okay, so down here at my force balance table, I'm going to go ahead then and link this to what's happening in AC. So we'll pull that down, and then here's what's happening in AD. We'll pull that down. Okay, so the D, the Y direction, we can force that to add to 0 by just changing what our weight is. But for the rest of it, you can see that we are not adding to 0 in the X or the Y direction. And what we can do with our sum is, and I'm going to actually add absolute value to this thing. So I'm going to say ABS because I want the numerical solution to force this to 0 without making one positive and one negative. That's going to be important. Okay, so here's our absolute values. And really, I'm going to say sum of all of these. So the goal is for X, Y, and Z, all three of these, to add to 0. Get to the smallest number possible. Okay, so this is the goal right here. And if we have everything in here right, I should be able to change numbers around up here. Maybe I'll do a split view just so we can look at the table and change numbers around. So if I change around my starting guess, ooh, that was the wrong way, right? So maybe 150. So you can play around with this and do kind of a hot cold game until you get the right answer, but we'll let the solver do that. So here we go. Here's the solver. And what we want to have happen is for this cell down here to become a minimum value. And we'll do that by changing around. Actually, all we need is just these two values, huh? We've got the weight figured out, so it's just AD and AC at this point. And then that Y direction. Okay, so cross your fingers. It's trying, you can see it trying. 101 and 785. Did we luck out? Oh my goodness. 101 and 785. Yay! Of course, we started this with some close values. But yeah, that's the solver. So if you don't want to mess around with the algebra, 2 equations, 2 unknowns, this stuff, you can also do the numerical method and set this up with a solver. And I'll let you do that for the exam too, if that's going to be easier for you. But yeah, a lot of pieces for this. It's really easy to get a direction in wrong or get one of these. So these take time to solve. They take some time.